Okay, so today we're going to learn how to solve equations algebraically. Yesterday we learned how to do it with a scale, with a balance scale, right? And what is the main thing we learned about an equation in relation to a balance scale? Anybody? Yes, Hunter.
Each set of numbers on the equal side of each other is something.
Right. The value on the right side is exactly the same value as the value on the left side. It may not look the same. It may look totally different. One might have 7 x's and a 2, and the other one might have 4 x's and a 15, right? Doesn't look the same, but the values have to be exactly the same. And then when there's an equal sign, that tells you they are the same. And so you can slowly simplify your equation to find out what one of those unknowns equals. It just always works. Did somebody have a question? Yes. Otherwise known as the golden rule of algebra. Do unto one side of the equation as you would do unto the other. You can do anything at all that you want to do to one side of the equation. Anything. As long as you're fair and you do the same thing to the other side. Then it will maintain its equality. Absolutely. So that's it. So we're going to talk now about solving equations algebraically. We're going to start very simple. We're actually going to start with one-step equations because every complex equation is made up of a series of one-step operations, right? So you'll solve them just like the one-step equation. Once we get this behind us, and everybody in this class knows it, and I hope we kind of think about this as working as a team. If some of you know this really well, get up when I'm having you guys practice. Get up and help some of the people that don't, so that we can, as a class and a team, move forward. Because everything, all the cool stuff that I want to teach you hinges on you knowing this. You have to know this, and then I can teach you some amazing stuff. So here we go. So the first thing I want to talk about before I actually solve one is, what are my 4 operations?
Multiplication, division, addition, and subtraction.
All right, so we'll start with addition, and then we'll say subtraction, and then we'll say multiplication, and then we will say division, right? All right, so now this is my next question. What are the opposite operations? Whoops. Opposite operations. What's the opposite of addition?
Subtraction.
So subtraction. So we're going to use this a lot. Subtraction. If I can spell it. Subtraction. The opposite of subtraction is, subtraction is? Addition. Okay, and opposite of multiplication? Division, divide. I'll just put divide. The opposite of division is multiply. Oops. Oh well. So that's going to be important for the first step that we're going to talk about. So if I give you a problem like this, x, so we're going to do a bunch of examples. I'm going to come over here. I think this
X equals
1. We've got x plus 13 is equal to 27. X plus 13 is equal to 27. Now on my balance scale, I said, well, I don't want that 13 there. I want to get rid of it. So I took 13 off, but I had to take it off both sides. I followed that golden rule of algebra, right? So the question is how can I take away the 13? It's a positive 13. You guys agree with me?
Yeah.
We're adding a positive 13. So what's the opposite of adding, Liam? Subtracting! You are brilliant, buddy. That's amazing. So this is what I'm going to show you, what I actually want to see on your paper. I don't want you doing these things in your head as much as starting to do. I want to see your process. And so what I'm doing is exactly what I'm expecting you guys to do. It doesn't take very long. It's like seconds or milliseconds sometimes, but it will help you get the answer right more often. If you do it in your head, which is a good thing to practice, go back and do it in this way too, right? So the opposite of 13 is negative 13. So I'm going to put negative 13 underneath the positive 13. But notice I have to do the same thing that I do on the left side of the equal sign. I have to do on the right side. So I'm going to say minus 13. and I'm going to draw a line. And that tells me I'm going to do my subtraction. And when I subtract, I start from the left side, and I work my way to the right. Don't start over here, and then do this, and then do this, and whatever. It doesn't work so well. You end up eventually forgetting to do something. So if you start on one side and work your way to the right, that's the way to do it. So, has this x been affected at all?
Nope.
No, I haven't taken anything away from it, so down here I just have an x. Now, what is 13 minus 13?
0.
Did you do that in your head? That's amazing. Okay, so that's 0. Now, do I have to write a plus 0?
No.
Nah. I mean, it's nothing, right? 0 is nothing, so just leave it as nothing. So that really just crosses out, right? And so now I can just say equals. Now, what is 27 minus 13? So if I write them right underneath each other, then it's really easy. 7 minus 3 is 4, and 1. So x is equal to 14. That was very easy, right? That wasn't so hard. Let's try another one. Example number 2. We got x plus 71 is equal to, why don't we say
75.
negative 21.
What?
Ooh, a negative number. We're going to
Yes.
try this. All right. So I've got the same thing here that I've got to do. I have x, and my goal, I didn't write this down. This is my goal. This is my goal always. Find 1x. Find 1x, yes. Unless it's another variable. Then it would be 1y or 1z or 1m. Yes, Amy. You have an answer. All right, but it's the process. Okay, tell me the process first. Help me.
Okay, so you subtract, so you take the opposite of 71, which is negative 71.
Right?
And so that's subtracting negative
The
71.
opposite of 71 is negative 71. And so whatever I did to this side of the equal sign is that place where it pivots, right? I've got to go to the other side. So I'm going to put minus 71 here, draw a line, and did I do anything to the x?
Nope.
No, so the x stays. What do I do here? 71 minus 71?
Yes.
0. So just forget about it. Equals. Think about it. I've got negative 21, and then I'm going negative 71 further. So I'm going to add the numbers and keep the sign.
Sign.
Negative 92. Do you guys see how I'm using the number line? See how I'm doing that? I'm saying, okay, here's 0. I go negative 21, and then I got to keep going negative 71. So I can tell that I'm going to add this to this, and it's just going to be negative, right? So there's our answer. X is equal to negative 92.
That's cool.
All right, so another example. 3. How about this? X minus 47 is equal to 22. All right, so we're going to use that same principle. The only trouble is, doggone it, somebody subtracted 47 instead of added 47. And I don't know what the heck I'm going to do now. Elizabeth, what would you do?
Are you supposed to add 47 to 22 or something?
Oh my God, that's brilliant, right? The opposite of negative 47 is positive 47. So we're going to put a plus 47 underneath the negative 47. And again, I did that to one side of the equation, so now I'm going to do it to the other, right? Is this right? I'm going to do it. So I did it to one side, now I'm going to do it to the other side, right?
Equal sign.
Oh, wait, the other side is the equal. Oh, right, shoot. I'm so glad you caught me, guys. Okay, so that was a plus 47. So I go to the other side of that equal sign and I put plus 47. And I draw my line. And what does that give me? X. And then this crosses out equals 69, right? Does everybody agree? 69.
Yeah.
All right, fabulous.
That's like a quick way to
4.
isolate the variable.
We'll do one more like that. So we got x minus 110 is equal to negative 215.
Gary?
Okay, yes.
What about the times where it goes like x plus something and equals to another x plus something? That's what was on my note.
Yeah, those are more complex, and right now what I'm trying to do is show you one-step equations, because all those complex ones are made up of a lot of one-step processes. So as long as you understand these, we'll get to that. Okay, we won't get there today, but we'll get there tomorrow probably. Today's Thursday, yeah. So okay, we've got x minus 110 is equal to negative 215. Right? A little hard to do that in your head. Some of you can, but it's still a little hard. It's not like x plus 2 equals 3, right? It's a little harder. So, oh my gosh, it's a negative 110. So what am I going to do? Everybody together. Add the opposite of negative 110 is positive 110, right? All right, and I did that to one side of the equal sign, so I got to do the same thing here. Plus 110. All right, now I've got from my left side, left to right, I go x. This crosses out, equals. Now what do I do? I've got different signs. I want somebody new, somebody that I haven't heard. Liam. So what do I do? I've got a negative 215 plus 110. Yeah, basically. Now, is the answer going to be positive or negative? I always figure out this.
You have to keep the sign of the larger.
Yeah, keep the sign of the larger, technically absolute value, right? So the sign, the larger number, the larger absolute value is the 215.
Oh, it's negative.
So we're going to keep that sign negative. And now it doesn't matter what we do. We've got the sign figured out. We're just going to subtract the 110 from 215. And what does that give us? 105. So it's negative 105.
Oh, that's cool.
So you guys have just done these two. You've just learned how to solve an equation, a one-step equation, when you have to add or when you have to subtract, right? Or when x is being added to or x is being subtracted. From, whatever. Okay, so now we're going to move on to multiplication and division. Yay. Okay, multiply. Okay, let's see. So let's say we have 1, 2, 3, 4, 5. Problem number 5. Let's say we have 5x equals 25. Now I know most of you know what x is, right? But still, that's okay. We're practicing right now. There is. All right. There's two ways to do this, right? There's two ways to do this. And they actually are the same thing, but they look different, but they're technically the same thing in math. But I'm going to show you both ways because some people like one way and some people like the other way. The first way is to do what we've been talking about. What is the 5 doing to the x?
Multiplying.
Yeah, it's multiplying. And my goal is what? What's my goal again?
To get
What could I do to 5 to make 5 equal to 1? Divide by 5, right?
Yeah.
With 5, does everybody agree with me that 5 over 5 equals 1?
Yeah.
Right? So immediately you could turn 5x into 1x. You guys get that?
Yeah.
Immediately by just putting a 5 in the denominator. Right? 5 divided by 5 is 1. But if I do that on the left side of the equal sign, I have to do it to the right side of the equal sign. So I'm going to put a line under this, I'm going to put a 5 here. So that becomes 1x, or x, equals 25. Remember, every fraction is a division problem. That is 25 divided by 5. 25 divided by 5. So 25 divided by 5 is 5, so there's our answer. X equals 5. Right? Pretty straightforward. I'm debating whether to teach the other method. Shall I? Do you want me to? Okay. So the other method is to think about what there's a rule that says if you have any number and you multiply it by its something or other, it will always equal 1.
Reciprocal.
Okay, everybody agree with me? Reciprocal?
Yeah.
So this is the rule. If I had x over 1 and I multiplied it times 1 over x, it would always equal 1. It would always equal 1. So 5 over 1 times 1 over 5 is 1. So another way to get turn 5x into 1x, I'll do it over here. 5x equals 25 is to multiply this.
Oh, you do it as a ratio?
Sorry, hang on. I turn it into a fraction, 5x over 1, and I'm just going to multiply it by the reciprocal, not with the x, just the number, the reciprocal of 5. Reciprocal of 5 is 1/5, right? So I'm going to multiply this times 1/5. Right? I don't have to put 5x over 1, but it technically is over 1. When you're multiplying fractions, sometimes in the beginning people find it easier to do that, but you don't have to. You could have just said, multiply this times 1/5. When you do that, the 5's cross out, and all you have left is x. So when you do this, I can cross reduce, right? 5 goes into 5 once, 5 goes into 25 5 times, 5 times 1 is 5 over 1, which is 5. So x is equal to 5.
That's no work.
So it's a little more work when it's just a whole number in front of the x. But you're going to find this is the way to solve it when it's not a whole number in front of the x. We'll see that in a few minutes. But all right, so let's do a couple more like this. All right, we got number 6. Let's say we have 12x equals 96. So I want it to be 1x. I want my goal is to find 1x. That says 12x. So the easiest way to turn 12x into 1x is put it over 12. 12 over 12 is 1, right? Everybody's with me, right? Does that make sense to you guys? 12 over 12 is 1. I got to do the same thing to the other side of the equal sign. So now I've got, that crosses out. I have x is equal to, what is it? 8. All right. All right, should we do another few of those? Yeah, let's do a couple more. 6, 7. All right, how about this? What if we had negative 4x equals negative 32? Negative 4x equals negative 32. So I wanted to say 1x. I don't want it to say negative 1x. I want to say 1x. So what would I divide this side by, Hunter?
Wouldn't you divide it by 4?
If I divided it by 4, it's a good guess. Watch this. If I divided it by 4, well, look what happens. That turns into a 1, but then I'm going to have a negative 1x, right? So can you see that it would be a good idea to divide it by negative 4? In other words, whatever the number is in front of the x, if it's positive, divide it by that positive number. If it's negative, divide it by that negative number. Does that make sense? All right, that'll give you, because look, when you have, what's negative divided by negative? Positive, right? Negative divided by negative is positive. When I see a negative over a negative in a fraction, I go like this.
Oh my god.
Immediately. You can either think of them as crossing out or you turning them into pluses, right? Now I got to do the same thing over here. Negative 4. Okay, here we go. I've got a negative over a negative again. What am I going to do? I'm going to do this. I know they're positive. I just got rid of them, right? Now what's 32 divided by 4? 8. So we know x is equal to 8. Pretty easy, right? One more. 8. One more. So we've got, where are we? So let's do negative 16x is equal to 48. I think that works, right?
Yeah.
Okay, so what would I do? I wanted to say 1x here. So, Tess, what would I put here? What would I do? Negative 16, I would divide this side by negative 16. Those would cross out, those would cross out. All I'd have left is an x. I'm going to divide this by negative 16. Let me think, somebody else. Sal. Positive divided by negative is what?
Negative.
Negative. All right, 48 divided by 16 is what? Who knows? 3? Okay, so it's going to be -3. There we go. So x is equal to -3. How many people are getting this? Fist to 5, just so I know. You guys rock. That's right. That's awesome. Okay, last one we're going to do. All right, the last one we're going to do. What did I just get up to? 8?
Yeah.
8? So we're at 9? Okay. 9. Here we go. 1/4 x is equal to, I don't know, 10. 1/4 x is equal to 10. Now, what is the 1/4 doing to the x? So what's the opposite operation of multiply? Division. So I could do the same thing I just did with the whole numbers, but it's a little more complicated when you do it that way. It's kind of interesting. But look, I could divide this side by 1/4, and I could divide this side by 1/4. But this is where you have to remember your operations and how you work with fractions, right? Remember, when I see it like this, I think of it like this. 1/4 divided by 1/4 is equal to 1/4. Remember, you always change a division fraction problem into a multiplication problem? Remember that? Right? So I put times, and then I flip this second one, so it's over 4/1. That's the reciprocal. Look, it's 1/4 times 4/1. That's its reciprocal, and that equals 1. So this is like extra work to do it this way. It's easier to just jump immediately into multiplying the fraction by its reciprocal. And that'll turn the 1/4 x into 1x. Do you see what I'm saying? Because otherwise, if you did this, you'd have to take this one extra step. It's still the same thing. It's just that I'm saying, let's skip this and go straight to this so that we don't have to do 2 steps, right? So if I'm going to do that, I'm going to change this. I'm going to do it like this. I'm going to say this is a fraction. So I'm going to say, okay, I'm going to multiply this times its reciprocal. And I'm going to multiply this times its reciprocal. I mean, that reciprocal. All right, so these cross out into 1. So we've got x is equal to, now how do you do this? So 10 times 4 is 40, over 1 times 1 is 1. 40 over 1 is 40, right? So I'll just say x is 40. Okay? They're really easy once you get the hang of them. 9, 10. Let's try another one. 2/3 x equals 5. That's fine. 2/3 x equals 5. What would I do? 2/3 x, that's a fraction. So how can I turn the 2/3 into a 1? Hunter. Multiply by its reciprocal. So immediately I go 3/2. Those will cross out as 1s. So that's going to be x equals, I've got to do 3/2. I'm going to make the 5/1 for now. 3/2 here. And 5 times 3 is 15. 1 times 2 is 2. So x is equal to 15 halves. I could leave it as that if I wanted to, as long as it's in reduced form. And I can't do anything more reduced. Or I could do a mixed number. And I'm okay with either, just so you know. I'm okay with either. You can leave it as 15 halves, or 7 1/2, right? 7 1/2. Either one is fine with me. Because the reason I say that is because a lot of times this is an easier number to use than this, right? If in mathematics, oftentimes when you have this, you're actually converting it to this, right?
Yes.
Because this is easier to multiply by, or add by, or whatever, right? Or subtract with. The only time this is really important, maybe not the only time, but a main time that this is important, is when you're graphing.
Oh.
Right? If I had a coordinate point that said, 15 halves, comma,
That wouldn't work.
7. Well, I don't know where that is,
15
right,
halves.
on my graph. So I'd have to say, oh, well, that's 7.5. Then I can go over 7 and then a half more, right? Then it's really useful to have it in that mixed number. But if it's not graphing, it's not that necessary. Yes?
Or you can make it complicated and then count each half 15 times and then you get it, but that's
Right.
like
Right.
the other way.
And then sometimes too, I mean, there are times when it's useful, like if you're trying to divvy up cookies, right?
Yeah.
Well, everybody gets 15 half cookies, right? That doesn't quite work, right? What is that, So you kind of need to know how many.
15 half cookies?
Right. Right? So, okay, so 9 or 10 and 11. All right, so now we're going to make it a little harder. Let's say we have negative 3/4 x equals, we'll just do 10, keep it simple. All right, negative 3/4 x equals 10. What would I do? I wanted to say positive 1x.
No, wait.
So somebody else, positive 1x. What would I do? Elizabeth.
What do you do? Negative 3/4 times negative 4/3.
Exactly. It's got to be the reciprocal of a negative number is a negative number, right? So I've got to do this times negative 4/3 times negative 4/3. Now, I'm going to just talk about something really quickly because I know that a lot of people get confused about this. Sometimes people wonder, well, where does the negative go with a fraction, right? So, like for example, okay, we're talking 4/3. Negative 4/3 equals negative 4/3, which equals 4 over negative 3.
What's the other say?
They're all identical. They're all identical. That value is the same as that value, it's the same as that value. And the reason why is every fraction is a division problem, right? This is a negative of whatever this is, and this is positive divided by positive is positive. So it's a negative, right? It's a positive that's been turned negative. This is a negative divided by a positive, which is a negative. This is a positive divided by a negative, which is a negative. So they're all identical. So it doesn't matter where you put the negative sign. You just have to have it, right? But you don't do this. You don't do two negatives. Like negative 4/3 does not equal, that does not equal negative 4 over negative 3. That does not work. Okay, is that clear? All right, so let's go back to this. So we've got negative 4/3 times negative 3/4. Well the negatives are going to become positive, so I can put I can just create positives. Those are going to turn into 1, so that's 1x. Now, here we've got 10 times negative 4 is negative 40 over 1 times 3 is 3. So it equals negative 40 over 3. And if I wanted to convert that, I could. I'm not sure what it would be. Ooh, I hurt my hand. It's going to be negative, what is it? 13 and 1/3. Yeah, that sounds right. Right? So that's it. That is what I want you to practice for homework. All right, for those of you, how many people feel you are way beyond this? I just want to know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
I mean, I understand it, but I'm just like...
Yeah. No. What I would rather, even if you understand it and you really get it, but you just feel like you need to practice it, I'd rather you practice this stuff. I'm going to give everybody this homework sheet for this, and I'm actually going to let you work on it now. And then for those who do not, for those who finish it quickly and want more challenge, I have another sheet for you. Okay, which will actually combine these steps. Right? You'll take all of these one-step things and you're going to combine it into something like this, where you have 2x plus 4 equals 12. Right? And we're going to talk about that one tomorrow. And then tomorrow we'll also get into even more complex
Wait, that's two separate questions, right?
Okay, that's it.